super excited to be with you here today. Chad Siebold here, along with Amy Burke with Redox Bionutrients. Amy, welcome.
Thanks for having me.
Yeah, excited to talk about the Cypher tool. We've went through it a couple different times with some customers, had a chance to see some different insights. I know we've got John Kelly joining us here in just a few minutes. John Kelly is the chief agronomist and co-founder actually of Bionutrients, going to dig deep into the weeds on the Cypher tool and really give us, I would call it more of a lesson around soil health, soil biology, soil chemistry. I'm excited to do it today.
Yeah, I would just add, Chad, we've been out in the Midwest talking to guys and actually doing some of the soil cycle reports right now, right before the freeze. So excited to dig in and show you guys the tools that we have available. And then, we can talk about how we can help.
Aim, as a producer, one of the things that I always talk about is how do I get early season opportunities to be able to get that, especially in corn, right? How do I get the length of the ear starting to be established, the number of kernels around? I think what you're doing here with this Cypher tool is looking at an early season available nutrients, and I think that's pretty exciting. And I'm gonna give you a teaser here for the folks that are on the line here. You're gonna see it. It's gonna take a minute or two to get to it. But when you talk about the prioritization of, you look at like our normal base saturation, like a normal Malic 3, if you look at this Cypher tool analysis, it definitely gives that prioritization of what you maybe normally have previously thought as like, gosh, I got to address this within my traditional soil sample. It'll give you that opportunity to look at that report and say, well, you know what, maybe not. I think John talks about opportunities, right? It doesn't say, hey, go out and throw the kitchen sink at this. It says, hey, this is something you should consider. And I think that's maybe a hidden opportunity.
Yeah, and you'll see this as we dig into the report, but it's not so much throwing the baby out with the bathwater, but we've got a nice side by side, and to your point, nice prioritization to say, where do I start? Right now, I know I've got some opportunities. Where do I go first? And so that's what the Cypher tool does.
I love it. So without further ado, Mr. John, thanks for joining us today. If we look at a traditional, what I'm going to call a chemical extraction like a Malic 3, we do get some good information from that. Some of that stuff, though, is pretty archaic, John.
Well, I've always said any information is good information. However, if the information we have is limited and we're making major agronomic decisions based on limited information, that can limit the potential, or at the very least, it could impair our allocation of budget to inputs that perhaps aren't going to have the greatest ROI. So the idea is, I love looking at any report, whether it's tissue, any type of soil analysis, and I enjoy that. The premise is, hey, if there's a way to identify additional information, that often can be very helpful for us.
Sure, I totally agree. It's a little diagnostic, right? To be able to sit back and look at. I love the name Cypher, as in decipher the results, decipher the report. Amazing name. One of the things within Total Acre is they've changed the theme from growing champions to unlocking your farm's potential. So I think there's a nice little tie in there too when you talk about potential. How do we know, right? Like, how do we know what to do? I think a lot of times we use the information that we have, or historically, John, a lot of us as producers have done the same thing because that's the way it was done before. That's a little bit different within the Total Acre group. They're always constantly looking at opportunities to get better. I think you were exposed to a few of the members maybe a couple of weeks ago. But maybe when you look at the tools and the opportunity to get better at what you do and unlocking some of that potential, when you talk about the Cypher tool, chemical extraction is one piece of the puzzle. The other piece of that puzzle is that soluble paste extraction. And so without without talking too much about that, maybe just high level, give us an understanding of what that is.
Yeah. I think that's an excellent question. I think that's probably going to be best accomplished through some graphics. Amy, it looks like you're running the PowerPoint show. Is that right? Okay. Why don't you go ahead and advance that, and let's just start talking about soil and the makeup of soil, and that'll lead into an answer to your question very soon, Chad, of what this is all about. So when we consider the three key factors in the soil: physical, chemical, biological. Where does the soil port where does that fit in, and what does that mean? Let's go ahead, the next one, Amy, if you will. So let's look at the total composition. If the green portion of this is looking at the soil from a volume standpoint. So half of a healthy soil is minerals. Okay. So that is your sand, silt, and clay. Go ahead and advance when you want there, Amy. You just can keep going. Now, when we say, yeah, go back to water and air, please. And we say, well, half the soil is actually what we refer to as pore space. And again, in a healthy soil, half of that pore space will be filled with water, and half it will be filled with air. I'll explain that in a moment. And then you see, depending on the soil, there's a little bit of organic matter, a little bit of chemicals. So you can go ahead and advance. And what we know is, on average, if you take a furrow slice, or 6 inches of soil by an acre, what that weighs 2 million pounds. And so whether you look at 6 inches or 12 inches of soil at 4 million pounds, that's the basis whereby a lot of calculations for nutrient content and so on are based. But one of the key perspectives, and this is an important one, is we have this 6 inches, and we're showing 110,000 pounds. What is that all about? Well, the water portion, where water is held in the soil, is referred to as the micro pore space. Now, micro pore space and macro pore space, which is the yellow, the differentiating factor in those two is the macro pore space water only moves by gravity. And in micro pore space, the water moves by what we call capillary action. So the water will move any direction. The key perspective here in this soil, in this 2 million pounds of soil, is virtually all of the action related to crop performance is occurring in the micropore space. And why is that? Because roots do not live in the soil, they live in a thin film of water in the micropore space. Roots cannot live in the macropore space because of the oxygen. It would die. So you're familiar with a couple of terms. You're familiar with what's referred to as field capacity. Well, field capacity, for those of you who've had experience taking a fundamental soils course, you know, field capacity, when the instructor hands out samples of soil and you're squeezing, you can't get any water out of it because the water is so tightly held. That is field capacity. That means micropore space full of water, macropore space full of air. Okay, so that's field capacity. You've also heard another term, which is permanent wilting point. And of course, you think, okay, well, that is a soil that's super dry. More precisely, permanent wilting point is when water starts to deplete in this micropore space where the roots reside, where they live. And as it depletes, it literally kills the roots, which is thus the term wilting point. Okay, so having said that, since the action, the microbial activity, 90% plus of all the beneficial microbial activity in the soil occurs within a couple centimeters of the root surface. So gas exchange, nutrient uptake, that is all happening in this micropore space. That's our rhizosphere. That's where it's all happening. Now, we show that plus or minus 110,000 pounds. Well, that 110,000 pounds represents the weight of the water in the micropore space, an acre by 6 inches at field capacity. The reason it's plus or minus is because the soil has varying abilities to hold moisture. So a soil with a high cation exchange capacity is going to have a much greater potential to hold uh, water, and therefore it's going to have a higher uh, soil solution weight, which is that term. 110,000 pounds would be a sandy loam soil. And so that number varies, and that's a number that when Redox takes data, we can calculate what that is based on Soil Science Society of America um, uh, ratios, where we can, there's 5 points that go into that, but we calculate that. And so that's just a quick perspective on the soil, what it's made of, which is probably a little different than what you may be accustomed to. Okay.
Yeah, John, just to clarify, I want to make sure that I heard that right. So the total soil solution weight in that top 6 inches, if I'm sitting in that, I think the example you used is like 110,000 pounds. That's somewhere in that silty loam range. If I were to be lower into that 95, 98, that's going to be more of a sandy. The heavier the weight would be more of a gumbo-y, heavy clay.
Correct.
Okay. I think that's a cool point, because on this report that I'm looking at, that is a key component within this Cypher analysis, I believe.
It is.
Cool.
And just a rough range, so you're familiar with this. Farm ground agronomic soils probably going to range somewhere from 80,000 pounds up to about 160,000. It's not uncommon to get lower or higher, but that's the range, just from a perspective standpoint.
Okay.
Okay. All right, Amy. Next point. With that background and perspective, I'd like to share some additional information that may be beneficial as you look at a soil, what it is, what it's made of. Well, on average, and we're talking nationwide, only about 0.3% of the soil is nutrients and chemicals. And of course, nutrients are chemicals. So a very small quantity of the soil is actually nutrients, 0.3% on average. In addition, only about 3% of those 0.3% are in what are referred to as plant available form, or the ionic form, the form the plant actually takes up, which is a good thing, because if it were 15%, it would kill the plant, because they're electrical in nature. So they would literally, the plant could not tolerate the electric conductivity. So in nature, we're looking about at that very small portion of the soil is nutrients. Yet most of what we're looking at in the soil is the chemical nutrient composition, but we need to keep that in perspective. Okay. Any comments or questions before we move to additional components of the soil?
I think if this wasn't set up as a webinar, that would be an aha moment for most. When you see that graph and you talk about 0.3% are chemicals of that soil makeup, and then 3% of that 0.3, very, I'm going to call it pequeño amounts, right? Very, very small, minute amounts. And when we go out as producers to go out and say, we are short, or we are lacking, the application rates that we traditionally would throw at something are usually heavier than what is needed, but it becomes what is available within whatever it is that we're applying. I know we'll get to that, John, but that's an aha for me, at least, and maybe some others on the line.
It is, and as we'll illustrate, sometimes when we think deficiencies or imbalances are huge, well, in reality, they're a lot easier to correct than we might think. So, okay.
Cool.
Let's see, Amy, you can go to the next slide and you can display all the bullet points if you'd like. I like this graphic that we did. Well, let's see, let's go back right there. Here we go. I like this graphic because this helps to visualize what we just talked about. You've seen that macropore, which drains by gravity, which quite frankly, after irrigation or a rain event, we want that to drain fairly quickly because what that's doing is that's pulling oxygen into the soil. You can see where these roots are residing in the micropore space. That is where the action, it's where all the action happens regarding the plant. Okay, I think we can go to the next one. So the oxygen gas exchange, I want to point out a couple things. We know oxygen is important in the soil. And we think of, okay, there's no roots in that macropore space. Well, then how does oxygen get into the micropore space? Because we know that's necessary for nutrient uptake. And to explain that, I want to share with you, I reside in the Rocky Mountains. And if you want to go fish for trout up in a pristine mountain stream, the dissolved oxygen content in that, beautiful mountain streams is 6 parts per million. Okay. And that's the level that the fish and the aquatic life can survive and do great. All right. Now let's go to the Mississippi Delta, to the so-called dead zone, where we know that the depleted oxygen levels is called a dead zone because it's depleted of oxygen. And I'm not going to go into the mode of action, but you know all about that. You're very familiar with that.
Mm-hmm.
Well, the difference there, it's called a dead zone because it's 3 parts per million dissolved oxygen. So visualize the subtle difference between a pristine mountain stream or the dead zone in the Mississippi Delta is very, very small.
Mm-hmm.
And if I were to compute 3 parts per million differential on an acre foot of water, you know, that would sit in a small bowl on my desk. It's very
Sure,
small.
sure.
So the gas exchange and how that works, it's very subtle, but it's also very important. And it also highlights how quickly in a saturated soil that doesn't drain, how quickly things can go wrong for us. Because as we get anaerobic, of course, that favors a lot of abiotic stress in the plant, which in turn favors conditioned and a susceptible plant wherein fungal pathogens, for example, can wreak havoc with our root system. So
Sure.
just understanding those dynamics is very beneficial, very helpful as we proceed in our discussion.
Yeah, and I just want to hit something here, John, because I had to go back and look at my notes, but micro pore space is water, macro is air. So if you're taking notes, just to reiterate here, I think that it resonates with me, but I had to go. I mean, come on, I'm not the smartest tool in the shed, right? I had to go back and look and cheat here.
Yes. And with that in mind, keep in mind that plants don't eat, they drink. So, nutrient movement, whether there's 3 mechanisms where nutrients get into the plant, but all of those involve water.
Sure. And I know you're going to get to this, but when I think about that water and I think the way that's measured, when you talk about that stream in parts per million, when I look at a traditional base saturation on a chemical extraction test, on what I look at for nutrients, it's all in parts per million, and it's in, the movement in that for available nutrients. It doesn't look that big. If I were to make an application, it's hard to see those swings. I'm sure that's what you're going to kind of talk about here. But to me, when you talk about the differences in an acre feet, because I'm an irrigator, that makes a ton of sense.
Yeah. Yeah. Okay. All right. As you're all aware, the soil has a net negative charge. The relative holding capacity of the soil is based on the composition of sand, silt, and clay. All of those have a negative charge. They can hold what we refer to as cations, the positively charged elements. So calcium, magnesium, potassium, sodium, hydrogen, zinc, manganese, copper, and so on. So there's an attraction that holds those. And the reason a heavier soil or higher cation exchange capacity soil holds more nutrients is there's more surface area. To illustrate that, looking at this graphic, which is good, it kind of shows there's a size difference. The surface area of a handful of sand. So if I had a handful of sand, I look at the surface area, just on roughly would be about 10 by 10 feet. Contrast that to me holding a handful of clay, and that surface area that would exceed the size of a football field. So, so keep that in mind as Iowa State comes to Salt Lake City tomorrow and to play Utah, which I think Iowa State is strongly favored. Anyway, that's the difference. So surface area, so that clay can hold on to a lot more nutrients than sand can. Okay.
I love it. That's a good visual, John, too. Not the Iowa State Cyclones and BYU, right? Like I know that they've had a loss, but if I think about that, the surface area of a handful of sand is 10 by 10. Same handful of clay as over a football field. If you were to just take that surface area, I'll be darned.
Yeah. In contrast, our negatively charged elements cannot attach to the soil colloids. Now, why do we see an accumulation of elements like phosphorus? Because when the soil report is extracting those, they're using strong acids that break those apart. So it's reading what's there, but they're tied up with other cations. Typically, phosphorus is tied up with calcium. So they're not attached to the soil colloids, rather they're tied up. They're part of that 97% of the nutrients. They're not in plant available form. So they're there. Nitrate, nitrogen, why does it not tend to react? It goes to the basic atomic weight and the valence, the characteristics of nitrate, nitrogen versus phosphorus. It has a weaker electrical charge, so it just wants to leach. And so just understand that. Sulfate sulfur doesn't leach quite as readily as nitrate nitrogen and does have a little stronger propensity to react with cations in the soil. But just for comparison there. Okay.
Okay.
All right. All right. Now, one of the key concepts, because we're going to talk a fair amount about soil health, is we're gonna make the case that one of the key principles behind soil health is soil chemistry. Particularly for Midwestern growers, this applies strongly because calcium is unique in its size and valence and the ability to flocculate the soil. So you're aware of this. The calcium will attach to one colloid, it'll attach to another. And in that process, it's literally improving the quality and the quantity of the micropore space. Now let's talk about some of the other cations that cannot perform that role.
So John, before you go there, let me just that flocculation might be, or flocculated soil. I think most probably understand that, but for those that don't understand that, it's essentially loosening, right? Or it's the creating that air pocket, that ability to have that movement within that flocculated soil. Is that a better term? I mean, explanation.
It is.
Cool.
And so, it's that flocculation that provides the opportunity for water and air to move appropriately to support root development and biological activity. Okay. So this is really critical and fundamental. if we were if we were talking to growers and regions, they're using a lot of irrigation water. The chemistry of that water now comes into play and how that affects flocculation. If you're in a non-irrigated farming operation, you're dealing with rain. Well, keep in mind that rain absorbs a lot of carbon dioxide before it hits the soil, and that carbon dioxide turns to carbonic acid in the water. And so rainwater has a moderately acidic pH. So in high rainfall areas, the trend, of course, is that hydrogen ends up displacing calcium on that soil colloid, which highlights the absolute necessity of liming where appropriate. And it's so critical. And if I had to point to one thing in the Midwest as far as maintaining good soil chemistry, is going to be that. When you need to lime, there's no substitute for that. You have to have X units of calcium carbonate reacting with X units of hydrogen to initiate that response. And there's other factors, of course. So very important. Now, magnesium has long been considered having the same benefit as calcium because they're both what are called divalent. They both have 2 positive charges. However, as you can see on this graphic, magnesium is very small. And for those of you who have high reserve magnesium soils, you know what happens. They get very sticky when they're wet, and they're very rock hard when they're dry. So in many equations, magnesium is given the equivalent of calcium. It's not true. One of the most common is the sodium absorption ratio. Gives the same weight to magnesium as calcium, and that is incorrect. But flocculate soil. And so the problem with excess sodium or excess hydrogen, or quite frankly, even excess potassium, is they only have 1 positive charge. So they can attach to one colloid, they cannot attach to another. What that does is disperses the soil or deflocculates the soil. That tightens the soil, that limits water and air movement, which in turn limits root and biological activity. So this concept is very important.
Question for you there. As an irrigator, high iron water. I'm not, just as an example for guys maybe that irrigate, high bicarbonate. I looked at one of my tests, and I have high bicarbonates, which means I have a propensity to have tighter soil, and I have issues. I would assume because of my water quality. So when I look at high bicarbonates, and I'm cheating a little bit because I'm kind of going back into again my test. I never have tested my water on my farm. I just knew that it was high in iron, right? Because it turned my pivots red. But the thing that stood out to me, and I think this is probably talking about some of that flocculation of soil, it tends to be tighter and unavailable or less available for nutrients. But I have high bicarbonate in my water, and I think in terms of in my soil as well.
Yeah,
Does that tie back to that rain the way you were talking about
it does. And so let's visit that for a minute. Water, when it comes out of it, whether you're getting surface deliveries like we do in the West, or well water, it tends to be in relative balance. In fact, so the water as it comes out, there's not a lot of reaction going on. But where you have cations like calcium or iron, you're going to have anions, negatively charged. So there's going to be a balance. So where you have calcium or you have magnesium, very, very rare to have any significant levels of potassium in water, or you have sodium. In turn, you're going to have chloride, sulfate, or bicarbonate, just the way it is.
Mm-hmm.
So the bicarbonate, which has a negative charge, actually is not super reactive in the water until the water evaporates. So visualize you irrigate with that water, the water evaporates. What happens? You're concentrating those salts, and the negative charge of bicarbonate, which is HCO3 with 1 negative charge, attaches to calcium or other cations and forms what we call a carbonate. Okay, so, and that's if you have a water softener in your house, that's what a water softener is doing. It's attracting and pulling out calcium and displacing it with sodium or potassium, which are softer. They don't, so they aren't hard water. So in your soil, what happened is literally you are creating lime. It could be magnesium carbonate, it could be calcium carbonate. You could have some iron carbonate going on, but it's evaporation, attraction, reaction. Now, the problem as well as the opportunity is now you've tied up important nutrients because those carbonates in that form, plant can't do anything with them. They have to go through a reaction to break those down. And you can do that two ways. You can do it with straight chemistry, which would be acid forming inputs like sulfur or sulfuric acid and so on, or you can do it biologically. Why biology? Well, promoting more biology produces more carbon dioxide in the soil. More carbon dioxide produces carbonic acid, which helps dissolve those carbonates. So when and where you employ different inputs to offset that really depend on your water chemistry and your soil conditions. But I want to point out some of the very most productive ground in the United States has moderate or even high bicarbonate levels. It need not be a limiting factor, but that's where understanding where it's taking your soil and how it's impairing crop performance comes in.
John, that's what has me intrigued, right? Because what the charges for those on the line here that are hearing John talk about charge, if this is the first time you've heard about charge and different anions, cations, that balance in between it, and I know you're going to get to this too, John, but that balance is everything in the world that we're trying to create a crop or grow a crop, and it's called homeostasis. And I think if you go clear back to probably sophomore year in high school, maybe even freshman year, maybe in Iowa where I'm from, maybe it was senior year, you had to get to college to get to that level. But it is the basics of everything we do is that balance. And I think what you're talking about here, John, too, is the understanding and knowing and better visual of what we can see and what we can't see with tools that we're going to talk about more. These charges affect balance, which in turn may or may not be showing you the real story and compared to what you're normally used to looking at. And I think that to me, again, another aha moment. Some of the things I like about what these tools that you bring to the market.
You're 100% correct. We always think of chemistry in the soil. We stop short of what's going on inside the plant. So we will visit that a little bit. Okay.
Mm-hmm.
We'll discuss that. Okay. Amy, that was probably a sign that I've spent too much time talking when she goes to the next line without being prompted. But dispersed soil, you can see in this example, sodium it's tightening that soil. It's impairing water movement. It's impairing root growth because it's tighter, literally. Okay.
Mm-hmm. Makes sense.
You all understand the sand, silt, and clay composition of your soil drives the texture. Okay. And here's that triangle. We aren't going to change that. And the only thing I'd like to say is whatever your soil is, you bought and paid for it. We can live within that framework as long as we understand some of the opportunities and limitations. All right, let's talk a little bit about the chemistry, because that's what the primary purpose of the soil report is. And let's go and advance to the next one, Amy, if you will. Soil health is on everybody's mind, and for good reason. Everyone, all of the universities, as well as private organizations, acknowledge that our soil health is actually in a slow decline. That's problematic because we need to increase our food production significantly in the next 26 years. We got to increase it by 50%. But there's really very little of any new arable land coming into production. So we've got to use the resources we have. So brings into question, okay, the soil health, if it's in decline, what can we do about it? I'll get right to the point here. One of the best news about soil health is it can be improved and corrected very dramatically and quickly if you understand the goals and objectives. Okay. And there are three factors that come into play. I've mentioned soil chemistry, how important that is. Fortunately to, our participants today, some of the soil chemistry conservative factors are not as great as some areas of the world or some areas of the country, wherein, we have irrigation water and we have to closely look at the chemistry makeup of that and how it's impacting our soil. The second, and I hope I made the case, first things first, if you got major chemical imbalances, you better correct them. And the key is where you have excess hydrogen and you displace that. If you have low calcium, low reserve magnesium, dolomitic limestone is a very beneficial input as well. This is not going to relate to most of you, but where you have excess sodium, that needs to be addressed. And there are ways to do that efficiently and effectively. The second key to soil health, and you're all familiar with this because they've made the case that you've got to grow roots. Why? Because roots drive biology. So if you have good chemistry and good quality roots, and sometimes good quantity of roots, but good quality of roots in a chemically nutrient balanced plant, that drives good biology. In addition, what we have found, in most cases, we see good performance upticks when we promote better biology with specific strategic carbon inputs. But those three come into play, and our experience has been you can take a scenario, look at it, identify the inputs, make sure that works in a budget framework, but you can make really good strides. Okay? Comments or questions on that?
Makes sense. I think you did a good job outlining each. I would like to maybe throw something out there too, because one of the confusing things, the first time we started kind of talking about the name Redox bionutrients, when you say biology, you're talking about the study of, and you're not talking about a biological product or a service that your company offers, right? You're literally talking about the science of, not the biological products that are in a jug, just to be clear.
Correct. And so think of it this way, is if you're dealing with good chemistry, good plant nutrition, and which will result in good root architecture, good root quality, biology follows.
Yep. Well said. Makes sense.
All right. You can go ahead and keep going there, Amy.
So if I may, John, just interrupt here just for just 1 second. And I know this is a little bit, so for those that have joined and are interested in kind of learning more about what this tool is. So John, the background and the heritage and the history that you have within the company, what you're going to see now is a lot of what I would call the technology that you've been able to develop over a period of time. And what you're going to see right now is the Cypher analysis, or the report that will basically showcase what John's talking about, is a different look inside, or a different look in how we can basically help depict what available nutrients are early in season.
Yeah, a little background. I went to school here in the Intermountain West, but I right out of college was hired by a very large agribusiness corporation based out of California, and worked on the production side. So I was in the production side of agriculture, and um, was introduced to different methodologies for analyzing soil. And one of the new methods was taking a chemical extraction, a traditional way of looking at soil, but also doing a soluble paste extraction. And a soluble paste extraction it's a protocol that is well defined by the Soil Science Society of America. It is that concept has been fairly widely adopted in some areas of the country. For example, in the West, it's widely used. In the Southeast, quite a bit. In some of the specialty markets, like in the golf market, very, very used it very extensively. But it may be new to you. So starting about 35 years ago, got familiar with it, and over the years we started developing algorithms or relationships we found that improved crop performance, or performance in this especially markets like the golf market. And so what you're looking at here is Redox does not own or operate a laboratory. We have no financial ties to any laboratory. What would we do is we've developed software where we can take data, crunch the numbers. So the way this works is a lab we've worked with quite a few labs. But the lab that has really provided us with great consistent data has been Logan Labs out of Ohio. And so if a sample is pulled, it goes to them. You indicate it's redox, and as soon as the data is collected, it shoots to our server. Our server runs our software, and then it's posted to the cloud. So that's how it works. And so what you're looking at here is an example of a report. And whereas in a traditional soil analysis is giving you about 15 data points, we specify 42. And as I mentioned earlier, we love those 15 data points. They give us a lot of information. Getting some additional information, the 42, it can be very beneficial from a perspective standpoint. And one of the things I'd like to highlight is, now we dive into this report, is what a soil report cannot do. It should not tell you what to do. What it should do is provide perspective of where the opportunities are. And I think in my experience, when we get over reliant in any objective measurement without standing back and looking at the big picture, it can lead to, at the very least, overspending on some inputs, or it can lead to some error. So I love information coming from a tissue report. I love information from a soil report. But when we live and breathe and die by those, sometimes we forget to step back and say, how's the crop look? Stick a shovel in the ground, see how things are going.
Yeah.
I hope that is an important perspective as we dive into this.
Yeah, John, maybe two things there. One is, and I know you haven't met David yet. I think you're going to meet him in Orlando here coming up, but it talks about there is no silver bullet, right? And so when you go back into what you're looking at as a, yes, perspective, but a sharper perspective or better insight. And one of the things that I look at here, and again, I'm looking at one here that's a little bit different than this, but this impressed me the first time I seen it, because it does a prioritization of what you should consider first and maybe not consider, until later on. but it also gives us a typical what I would call the Malic 3 or a base chemical extraction as well. And so as I look at the compare and contrast, to me, it is I think you said perspective, but it really gives a better understanding of I think it's well said right here in this report, prioritization. Where do I not just spend money, but where do I spend time? Do I need to go to that part of the field or a different field to be able to go out and look at what we're actually seeing, and again, taking into account what's in the report as well, kind of visual and physical.
Well said. You can go back one more, Amy, and I'll make one quick comment on this. This is when it's all said and done, you get all this information. What's helpful is what's called a priority chart, which you have everything from low priority to high priority. And I'll just say that when we focus our agronomic efforts on the high priority items, we tend to see improvements in crop performance. Okay. All right, now we can move forward, Amy. And again, I'll just take every time you move a slide forward, that's a great hint that I'm talking too much.
Slap on.
So the report here, it's great to see things side by side. So a perfect example is you go to the top and you have chemical extraction, and traditional chemical extraction is going to say, okay, yeah, I've got 71% base saturation calcium. Everything looks great. Calcium is not an opportunity. But hold on. We go to the right, the soluble paste extraction, and based on the algorithms, say, no, there actually is an opportunity. Now, it doesn't mean it's a problem soil. It doesn't mean the crop's going to die. But what it is saying is, if our agronomic practices will improve calcium availability in the soil, we stand to benefit, specifically at the correct stages from a plant physiology standpoint. So we can go through all of it, but the idea of that is to steer us towards some opportunities. Okay.
And John, too, I think when you look at when this occurs, or when we should be doing this as a producer, is a fall soil analysis for what I would call early season vigor opportunities, right? So you're looking at strategies, from that plant date all the way up into like a V4 application strategy, right? I mean, that's the window of time you're looking at to be able to make those adjustments.
I would say as a rule, you would pull a soil sample when you've traditionally done it. I don't want to get too deep in this, but end season samples pulled right out of the root zone. Some of the elements that are going to be most affected by input is, well, if you've just done a nitrogen application, that's going to show up. The rest of the elements tend to be fairly stable. And keep in mind, with a sample, you pull a sample, whether it's wet or dry, you pull that sample, it goes to the lab. First thing you do is drive every ounce of moisture out of that soil. They literally bake it, because they have to start that way so that they can do their reactions. And this soluble paste extraction, the methodology there is where it's a prescribed method where you add deionized water and put it under vacuum for 24 hours. And as that vacuum pulls off water, it's pulling off the soluble nutrients. So you have an idea of, okay, what's the plant seeing? So when we look at different extraction methods, there's no right or wrong. There's just different methods. So ammonium acetate, Olsen, which is utilized in areas where you have more alkaline pHs, for example. Why do we like the Malic 3? Not that it's better or right, but it tends to be more uniform across all pH ranges. Far and away, the Malic 3 is the fastest growing method for that reason, consistency. So keep in mind, if your lab has been pulling ammonium acetate or doing ammonium acetate calcium, magnesium levels, and you Malik 3, it's going to come out different. Not a lot, but it'll be different. And don't lose any sleep over that. That is simply different methods are going to pull out different quantities. There also is in some areas of the country, there's a methodology called weak acid, which is a Morgan or carbon dioxide extraction. Does have the idea there is you want to mimic more what kind of the root is doing in the soil. I think it has some validity. I think those that use that are developing some measurements where they can determine what it means. I personally am not experienced enough with those to actually come to a conclusion. The other thing is, on the soluble paste extraction, the protocol is deionized water. Some consultants say, oh no, you got to use your irrigation water. I will tell you that our algorithms are based on deionized water. Chemistry, water is the greatest influence on soil chemistry, whether it's rain or irrigation, and that impact of that is already had its impact, and all we want to do is see what it's done. So there are some that insist, oh, I want to use my own irrigation water. That's fine. All you're doing is adding the salts in your water to the salts that naturally would come out in soluble paste extraction. Okay.
Makes sense. Makes sense. John, just for the folks on the line here, a couple different things I just wanted to touch base on. One, and maybe this is, I know we've talked about this, but I just want to kind of give kind of a level set. Is one of the cool things within Total Acre is as a part of the YMS or as a member and putting information into the YMS system, folks are required to pull 2.5 acre grids with base saturations early. And those are usually done every other year-ish. But that's kind of that baseline, and then followed by tissue samples based off GDUs and plant dates. And so my question earlier kind of relates back to is we know we have a ton of good history of base saturation levels, which is most likely, I think they're always Malik 3s. But I think, and again, for the folks on the line, it's not that anything that Total Acre has done is not usable. So don't get that twisted. It is what you talked about earlier is that extra insight that you can see. And I think there's probably a correlation potentially to say, hey, historically, what of your base saturation? That's probably down the road, but what can we do today, right? And then that early season, I'm going to go back to that early season vigor because I see this as an opportunity to be able to take advantage of what I want, which is I want number kernels around and I want length of that ear. And if I can mitigate stress early by understanding what my limiting factors are based off of what I would call it, I think you call it, it's not the key opportunities, but the prioritization, right? I think, and correct me if I'm wrong, John, I think with a Cypher soil analysis, I'm going to be able to have a better chance of making that right decision early than just using a traditional base saturation in trying to be successful. Is that a correct statement?
That's possible, but I would also be quick to point out I would continue doing what you're doing because you have a lab with specific data and you have a track record. So I would think of this as a complement or an opportunity to identify, hey, here's my higher performing ground versus some that doesn't do as well. What are some of the differences? I would use this as an opportunity to identify additional perspective. I wouldn't change your process, midstream here. I just don't think that makes sense. So that's how I would use that. Would use this.
Sure. Yeah, no, I'm not suggesting we do, but I think, like you just talked about, is this in addition to what it is that we're doing today within Total Acre gives us additional insights. Without that, we still have a great opportunity, but it gives us maybe a sharper view into again. I hope I'm not saying this wrong, but I keep talking about early season vigor, right? What can we do about early season? Because, and as well as I do, from the time the plant's just coming out of the ground to the time it's 3-4 inches tall, that's an important time frame for us to be able to make that the right decisions. We can't get that back.
That's correct. And in my experience, you just can't make up for that early season performance when you're trying to drive yield. Yep. Okay. Amy, I think I'm being too talkative here, so I will keep moving. Again, side by side, you can go forward another one. This may be a little bit eye-opening for you. And since this is recorded, you can go back and do this, but trust me, you know how, and this is a very, very sandy soil. Probably they selected one out of California, so we weren't picking anybody. This is a CEC of 4.8, so beach stand, all right?
Mm.
And so we showed 693.9 parts per million calcium. You know how to do that. You multiply by 2. So I've got, just under 1,400 pounds of total calcium. However, to calculate the amount of soluble calcium in that acre by 6 inches is different. You take that parts per million, divided by million, because it's in million. You multiply it by the soil solution weight, which in this case is 87,411. All right. Remember what that is? That is the weight of water at field capacity. That why? Because that's where all the action happens. You do the math on that. I have less than a pound of soluble calcium in the entire acre. Now, that's not bad or wrong, but it is an opportunity. And then if in this case, the key opportunities highlighted, one of them is optimum soluble calcium. So then it comes to agronomic decisions to drive that is, what can I do to improve that? Is it going to be the soil, or is it going to be the plant, or is it going to be both? And so that starts the conversation of saying, okay, during early development, during early pre-reproductive stage, does the plant have enough calcium to run the system? Okay, so we can go forward, Amy, but that's the perspective we have there. And in most cases, it's not that difficult to correct or make course correction. And I'll just point out here, very, very common, some things like bicarbonate, like chloride, only run out of a saturated paste. You're not going to get that on a chemical extraction. But I'd like to point out that here we're going to look at these micronutrient levels where, okay, copper, yeah, it shows a little bit low, but very low. Zinc is showing it in the chemical extraction. I got plenty of zinc, but very poor zinc availability. That helps us identify, okay, that may be an opportunity for us. Okay, go ahead and keep moving, Amy. Again, we don't want to look at our chemical side, man, everything's great, when maybe there are some key opportunities. Okay, we'll keep moving. This one I would like to just spend a couple minutes on. All right. Chad, you laid the groundwork earlier when you started about electrical charge. So we know chemistry is electricity, and we think of the soil, we often forget of about the plant. The plant must balance itself electrically. There has to be an electrical balance. There must be an equal amount of positive charged elements as negative charge. In any crop, whether it's corn or strawberries, most of the negative electrical charge, negatively charged, comes from nitrate nitrogen. Most of the positive charge comes from potassium. Okay. Now, because I said the plant must balance itself. When imbalances occur, the energy, which is a byproduct of photosynthesis, is redirected to balancing itself rather than producing more kernels and better cobs. Okay.
I want to say that again while you take a drink, because to me, that is everything. when you talk about the energy. So if you're not in balance, and this again, this resonated with me a few months ago when we talked about this, was if we do have an imbalance, that energy that would normally energy nutrients, that energy that would have been traditionally spent to build yield is now correcting stress, which is that imbalance. That's an aha for me, because when I look at that tip back in my ear, I've said or heard said before, I run out of gas. Well, that's not necessarily the case, right? You might have enough nutrient availability to that plant, but there's an imbalance or some sort of an abiotic stress that says, why did we not fill out the last 2 inches of that cob because of something else happened? So that energy diversion is what we're talking about right now.
100%. 100%. And really, when we think about crop performance, about energy allocation, and if we're robbing energy to balance itself constantly rather than putting that energy resources into productivity, that's an opportunity. Likewise in the soil. So if you look at this graphic on the left, it's what we call the soluble cation anion ratio. And you see the optimum would be, we would have higher soluble cations than anions. Why? It's harder to get those cations plant available in the plant available form. So think about calcium, magnesium, potassium, harder.
Mm-hmm.
Where's our actual? So we see here, okay, it's not terrible, but there's a distinct opportunity here. And when we take that information, we take this soil report, we say, okay, that's going to help direct our agronomic decisions on the crop and how to redirect that plant energy towards benefits rather than just balancing itself all the time. Okay, next
So
please.
I think that's pretty interesting. And I think when you talk about balance too, and I just, one thing that I think's interesting, we haven't said a word about a product, but I think there is something that interesting there, John, before it's not an advertisement, but I do believe when you talk about a redox active substrate, these are opportunities to be able to have products that are traditionally used in the field today that actually can take or give a charge to put a plant within balance. And oh, by the way, there is a macronutrient or other nutrients that are with that product. And that is a unique feature, I think, of what some of the products and services that you offer in the marketplace, John.
You said it very well. The bottom line is the biostimulant composition of redox products are designed to redirect that energy so the plant doesn't have to waste energy on neutralizing these oxidants or stress. Okay, next please. Some highlights. First of all, I'd like to just say from nitrogen on a soil report, there are different methods. Do not rely on them. Why? Because nitrogen in plant available form is highly dynamic. The stable forms in the soil do not necessarily correlate to high nitrogen availability. So you need to go off other factors, your yield, your history and experience. And so keep that in mind. When it comes to phosphorus, we know the relative inefficiency of phosphorus, and I'll just say there are opportunities to protect phosphorus from undesirable reactions. We're not going to talk about that. We are going to talk about the importance of redirecting that plant from an energy standpoint to the soil, because the plant drives soil microbiology. The plant will exude up to 70% of all the photosynthase produces. All that energy will go out the root system. When a plant is more in balance, electrical balance, it has more capacity to exude more energy out the soil and draw more biology, which in turn improves phosphorus, calcium, magnesium, micronutrient availability, strongly impacts those. Okay.
So you're talking about nutrient uptake. It's available and uptake. If we are within balance, that nutrient that maybe traditionally is tied up becomes more available and can be basically used.
Correct. If you think of potassium, think less about units, think about strategic timing and feeding the plant in season. Think about potassium requirements in a plant being driven by relative water take up, so respiration and so on. Calcium, we could talk forever about calcium, but again, whether it's calcium or micronutrients, first things first, let's think about what's driving that plant and our practices and inputs that are redirect that energy towards productivity. Okay, we can go forward, Amy. All right.
Calcium's a big one. Calcium's a big one there too. And I
that.
won't. Calcium's a big one there too. I'm sure there's going to be some questions maybe down the line on those, but better cell wall strength, better. I mean, it's a buzzword, I think, in the industry. You hear it all the time. Not all calcium's created equally, and I'm sure that when we talk about calcium, maybe in a different setting, John, we could probably talk, like you said, for half a day on that. But I do.
We could, but I since you brought it up, I would like to bring up one point is there is this notion that, well, I don't really need to even think about calcium unless I need to lime my soil. Okay, I'm all for liming when it's necessary, but calcium is what in cell wall strength, yes, very important. Soil structure, very important. But calcium is critical to cellular signaling. So think about a corn crop that we have redirected energy toward better biology out that root system. You've got better calcium uptake, which is going to help enable that plant to allocate energy to performance, to reduced abiotic stress, to reduced abiotic stress that leads to biotic stress. So you will, as time goes on, I don't want to overwhelm, but there are important calcium opportunities.
Yeah, and I would. This is why I like talking to you, John. I get a little geeked up about it because when you talk about things that we can correct or prevent, it does get us in a position to think of a finely tuned athlete, right? If I'm in great shape and I can run a marathon and I've got the nutrients to get through it, I'm not as susceptible to some of the things that could happen, right? So the difference between abiotic stress and biotic stress, for those who are kind of wondering, and I'm not going to go into a ton of detail here, but biotic stress is things that we could probably prevent if we were a finely tuned athlete in a field, right? If we're not, then that's when the biotic stress happens. And I think what you just talked about kind of hits home for me too, that, calcium's a big piece of that allows us to be able to allocate that energy to be a finely tuned athlete in that race. Good stuff, John. There's a lot there. And Amy, when I sit back and I look what John just talked about, I look at opportunities, right? And those opportunities, however small they may seem, can make an impact on somebody's operation. So I guess when we look at the opportunity between, now and between a guy's getting in the cab, right, for planting, we probably want to do it sooner than later. Obviously, where we're at, it's going to be a little chilly. Maybe the ground's frozen, but how do we get an opportunity to go out there and actually work this Cypher tool?
Yeah, I would say, Chad, just reach out to either myself or to Tyler Jones. We are the Midwest team. Our cell phone numbers are right there. You can also go online to Redox Grows to the Midwest landing page. Then you can do a contact us form. Just shoot us a note and say, hey, I'm interested in getting a Cypher tool report. We will ship you out a soil kit that'll give you a submission form as well as some little baggies that you can fill out. Get out there before the ground is frozen, or we can do it in the spring. And then from there, once the report comes in, we'll set up a follow-up call. We'll go through the results, and then we can have a conversation about what's next.
I love it. Exciting stuff. You said a lot. You said it all. Plant charge balance, the Cypher analysis tool. Great stuff. Thanks, Amy.
Oh, thank you.